So I got curious some more about efficiency. My code was only handling a couple of hundred cubes with no problem, and Lucas was reporting thousands of cubes, and some people in the class are reporting thousands of cubes. So I was wondering, what am I doing wrong? So the consensus when I started talking to people was maybe you shouldn't be creating buffers so often. So let's take a look at what we're doing. So inside of my render all shapes function, the first thing I do is I draw this map. And now I've broken my draw map function for the moment to ignore my actual map and to just loop 32 by 32, put cubes in all the spots. So that's 1,000 cubes. And then I'm doing it twice and just putting it back in the same place so that I have 2,000 cubes being drawn so that I have some reasonable number that's happening right now. So this is exactly what did I have before. So what's the performance that I'm getting? So right now with 2,000 cubes being drawn, oh, and I've turned off all of my texture and everything in order to just simplify the problem to see what's going on right now. So if I come over and I try to rotate, I'm a little bit laggy. I can't quite get it with 2,000. If I just let it sit here and just animate, then I can get, I don't know, it's taking like, let's say 30, 40 milliseconds to render a frame, and I don't know, somewhere 20 to 30 frames per second, something like this is the time frame that I'm getting. So what can we do to speed this up? So it was suggested that creating buffers is a problem. So let's talk about that for a little bit. So where do I actually create the buffers and draw? So I'm drawing cubes. So if we remember, inside of our cube function, we're setting up a bunch of vertices, and then we're calling draw triangle 3D. So let's go take a look at draw triangle 3D. So in draw triangle 3D, I've already commented and made some changes here, but we'll talk about this. So what was I doing? I was calling GL create buffer and getting a new buffer, and then binding the buffer, and then doing vertex attribute pointer, enabling the vertex attribute pointer. Now I was doing this for each cube, so this is happening 2,000 times per frame. And one suggestion was, well, this stuff doesn't have to happen for every time. You're using the same kind of buffer. You already have a buffer created. Just send new data to the buffer and redraw. Why do you have to go recreate all this stuff? So I've taken this extra initialization stuff and made it a init triangle 3D function. And that's what I put up here, an init triangle 3D. So this is exactly the same calls, just moved over into another function, and I've renamed it to have a global vertex buffer, and we'll see why in a minute. I want to do that. So I started off with null, and so I'm calling this. So this is exactly the same code that was running, just with this taken out into a different thing. But now what can I do is I can say, well, the first time through this loop, when my vertex buffer is null, then we're going to initialize this triangle, and then after that, we're not going to initialize the triangle anymore. So let's take a look at what happens if we do this. Doesn't look like a whole lot of change. So we didn't get a lot of performance improvement from doing this directly. So this change is okay. My code can still run, even though I'm only doing this once, because these things aren't required to be done multiple times. But I didn't get a huge performance hit from just doing it. And remember, I'm playing a dangerous game here. All of this setup matters. This setup is the way that I expect these vertices to be. I don't have any UV coordinates in here. Remember, I had another function called draw triangle 3D UV. And in this function, I actually was having two different buffers. I was having a buffer for doing vertices and a buffer for doing UV. And now in this case, I'm creating multiple buffers and binding them in different ways. So if I leave my binding as it was done for this, when I call over here, I'm going to have some trouble because it's not the same thing that I'm setting up and binding. So this can happen only once if I'm making the same calls every time and using the buffer in the same way. So what I've done to protect myself here is I've just down here, I've set my buffer back to null if I happen to be calling this other version of the function. Now I have that turned off right now. You see I don't have any textures going. But if I did, I want to make sure that when I need to, I do really go and reset up the correct buffers for this location. Okay, so in terms of performance improvements, so-so, but I'll leave it in because it seems like it should do something. We'll revisit this again later on. So what else could it be? What are other things that we could do? So the next thing that was suggested to me was, maybe it has to do with the fact that you're doing a new cube. You're calling new cube every time inside inside this loop. So I'm calling new cube 2,000 times. That's a lot of new memory being allocated. Maybe I don't need to do that. Maybe I can pull that out and put it on the outside of the loop and just keep reusing the same cube. So let's go take a look at that and see if we get any performance improvement from that. Oh, so now we see that there's some performance improvement. Now I'm seeing numbers more like 15 milliseconds. So there is something that was going on here, right? We were previously seeing 20, 30, 40. Now we're seeing 15, 20, something like this in terms of our milliseconds to draw a frame. So just being careful about where do we go and create new objects seems like that can actually have some gain. And that was a super simple change, right? This change was only in, where am I at? This change was only inside of this draw map function, right? So we moved it. I'm going to do it live here so that we can see the difference. So I just changed it in this draw map. I'm now doing it live in my Chrome browser. When I hit save, you see that my milliseconds gets longer because I've moved this new cube inside. So if you're drawing a map and looping over your map in order to place cubes, and you're doing this inside of your render loop every time, be careful about where you're allocating memory. Reusing a piece of memory that you had for your next draw seems like it can be a place that you can save. Okay, what else can we try to do to get some? Okay, so the next thing that I looked at was, well, since this memory allocation was causing me some trouble, maybe I should go look inside my cube, see what am I doing when I actually call these functions, and make sure there's not some more memory getting allocated someplace down here. So I go down inside my render cube, and inside render fast, what do we have happening? Well, we're making an array, and then we're doing all of this concat stuff on the array, concat stuff on the array, all these vertices. There's no reason we have to redo this every time, right? So creating this array, this is happening every time. So I was wondering, well, maybe I don't want to create this every time. Maybe I'll just make it part of cube, that all of these vertices, which are staying constant, are just created with the cube, and they just stay there, and I don't have to go dynamically create it every time. So I changed my definition of the cube to have a property, the cube vertices, and this is the list of all the vertices. This is exactly the array which was getting created down here inside my render fast. And I was doing it here with all these concat functions, but now I've just moved it into a single array. And because I don't want to destroy this function, because I want to be able to compare, I've created another function called render faster. And so what's going on inside render faster? So I've done a couple of things. So we have to be on the this was the right version. Okay, so what am I doing? First of all, I took whatever was happening inside the cube and I've just moved it inside this function. So here we were creating this vertices. We were calling draw triangle 3D. Here's my draw triangle 3D. The only thing that's happening inside draw triangle 3D is I'm checking if I need to init the triangle. I'm doing buffer data and draw arrays. So instead of calling draw triangle 3D, because I want to be able to see where am I making my changes and what's going on, I moved it over here into this render faster. So I set up my passing uniforms. I check my vertex buffer. I send the data, and then I draw arrays. So this render faster is exactly the same as this, except for this stop cube verts is containing the pre-made vertices, and I'm not doing all of this concat every single time. So let's change over to render faster and see what kinds of performance changes we get. Actually, I'm going to do it over here first. So if we change this to render faster and we hit go, see, now our numbers are getting smaller. So we're getting something that is running much faster. We're supposed to have this cube outside also. So let's do this. Now we're seeing numbers which are like 7, 8, 9 as opposed to 30. So another change that happened here is, in addition to pulling the cube out, I changed my naming of my render function, but really the only thing that happened in this changing of the render function between render fast and render faster is over here. Rather than building my list of vertices every time, I've now declared it up here in the top. So let's see what else can we get. So we're now down here in our render faster where we're passing some things, and we now have this call where we're passing these pre-made vertices. But now I notice another place where I'm allocating memory. I'm doing this new float 32 array every single time. So this seems unfortunate. Why do I have to do this conversion every time? This is now a constant array. It's not that I just built it. So maybe I can get rid of calling this new 32 float every time. So what am I going to do? I'm going to create that also. So I actually have two versions that I've created because I want to be able to test back and forth. So here's what we were using. This .cubeverts, this is a JavaScript array that's getting defined with all the vertices. Now here I've designed one and I've called it verts32. And I'm going to define this thing to start with as a float 32 array so that I don't have to make that change every single time when I'm running. So what's that going to mean? That's going to mean down here in my render, I'm going to use a different version where I don't do this conversion every time. I'm just going to pass in this pre-made array. So let's just go over here, and we should be able to do this directly in our cube. So inside render faster, rather than using this line, we're going to use this line. Wow, look at that. Now we're down to, say, 2 milliseconds. So I don't know, 300-400 frames per second, something like this. I don't know. We've so far gotten maybe a 10x speed up over what we had before. So what are the things that we've done? We've gone and we've looked at not calling create buffers and these things so often. We've looked at memory allocation. And in fact, most of our performance increase seems to have come from memory allocation issues. So even though JavaScript is a language with garbage collection, and it seems like you don't really need to worry too much about the memory, I guess it turns out you do need to worry about the memory, because if you allocate too many things, you're going to get slow. So there's one more thing I wanted to investigate. Remember, the first thing we looked at was, what if we don't do all this initialization every single cube? What if we do the initialization of the create buffers, bind buffers only one time? And we found that it didn't really make that much difference. But now we've got things sped up so much, maybe we'll be able to see the difference. So I'm going to comment out this if statement so that when I call render faster, it's going to call this init triangle 3D every single time. So let's see whether it's going to make any difference. So now I've saved that. And so now we see, oh, we're up 4, 5, 6, 7, 8, something like this. So this versus the 2 milliseconds that we were having before. So it turns out that this is actually making a difference. That it is desirable inside of our triangle to don't do this every single time that we need to draw something. If we pull it out, we can get some performance. We just couldn't see it initially because everything else was slowing us down that much too. So in combination, okay, I got 10x here. I think what you need to do if you want to get performance enhancements is to go through your code and look for every single place you're allocating new memory, right? So here I had a new float 32 array inside of my cube class. When I went over into my draw map function, I was calling new cube. And you need to be very conservative about allocating new things whenever that's happening inside the middle of a loop, including your render loop, including happening every frame. So looking for places that you can try to reduce this down, I think is a place you can get performance enhancements. By no means is my little investigation here exhaustive. You notice my textures are still off. Something that I have not investigated is if you're using two different buffers, so you need to be able to pass UVs and you need to be able to pass vertices, is that okay to be in two different buffers? Or is that causing a problem? Well, I haven't investigated that yet here. There's a variety of other things that are not in this little study I did, but I just wanted to spend a couple hours and then record a short video for you, just to see what are the kinds of things so that you can go and potentially grab some of these ideas and pull them into your code.